All right, thanks everyone for joining in. My name is Richie, and I'm a data scientist at Wealthsimple. And today I'm honored to speak about some of the experiences that we had while building a topic modeling model called Ernie to accelerate some of the model development process using LLM. Hopefully you can do the same as well. So who are we? So if you're not familiar with Wealthsimple, we offer 4 different big services. One is managed investing. We just set the money on, just let it do the work. Trading cryptos and stocks, having some like a prepaid debit where you can earn 4 to 5% interest rate on your checking account, as well as like a tax, which is like a free tax software. So given for this product, there's a lot of opportunities for us to leverage machine learning, and that's what data products is about. So we have data delivery, which is like data engineering perspective, ML platform that does sets up infra for us to train or deploy some of the models. And then where I am is the data science components, where it's like trying to find where we can fit machine learning applications into some of these products, either to improve client experiences, reduce some of the operations toils, and so on. And recently, we've been interested a lot in applying LLMs into our products, which one of this is part of the use case. So a little bit about myself. I graduated McGill University studying accounting, where my first job was at Bell. I'm currently a little bit more than halfway done through master's at Georgia Tech for CS, working at Wealthsimple. So then on the right, you see me in the suits. Now that I'm working at Wealthsimple and in CS, I just wear teachers to work. All right, so let me go straight into the problem context. So this is the help center that that clients go through when they're asking questions. They can either go through the chatbot or like an email ticket, or through phone. We're gonna be focusing on the email side, which basically this problem is applicable for all 3 channels. So when they click on submit a request, this is the screen they see. You need to select from these dropdowns, like I have a question about how to use Wealthsimple. I have a feedback about a feature, something isn't working. Now, this isn't great because like for someone, something isn't working is probably encompassing a lot of things, right? Versus I have a question about how to use Wealthsimple. Also, whenever you're clicking on the main topic, you need to click a subtopic, which there's a lot of drop downs for, and it's a lot of hassle. And I don't know about you, but if I'm the customer, I am reluctant to choose the correct one because I don't know if I'm making the right choice, or either that I'm just too lazy to pick one of them, and I'm already frustrated. So can we do better? And that's the conversation that I had with some of the stakeholders during lunch, and developed some POCs, and we decided that we can. So the project goal for this model is that, 1, we want smoother experience for the clients, as well as improve the service level agreements. As I said, clients might be already frustrated, so there's no point of us trying to make it even harder than it already is. And also, whenever this ticket comes in, they need to be manually routed by a SMEs, subject matter experts. Now, that means that unless that ticket is manually routed, it just sits in the backlog, which means that it is taking longer for the ticket to be resolved. And obviously, the manual labor has the operations toil. So then less time doing manual labor, it opens up opportunity for us to do more productive things. And lastly, better analytics. The dropdown that you saw earlier isn't nowhere representative of all the issues that we get. Also, it doesn't help us understand the trends and monitor new issues reliably. So some of the techniques we tested includes LDA, which is a pretty much traditional choice for anyone interested in topic modeling. Also, one honorable mention is the BERTopic, which basically uses the sentence BERT in the underlying layer for the embedding conversion, and then use some sort of clustering algorithms to get a list of topics. So you can see an example on the bottom left. So the -1 is just other, so we can kind of ignore that, but that's also an issue. We have 4,600 whatever in the other category, which isn't obviously great. When you look at some of the examples like Jesus, Bible, Christian faith, you can kind of tell where this is going, though I can't really semantically tell what the hell I'm talking about, right? And this is a problem because it's not digestible for the end user, and we might have an exercise where we convert this into a semantic context, which one of the problem will be accuracy, and the other thing is that whenever you're rerunning this, you're going to have inconsistent results based on your training data and whatnot. So, and there's a lot of noise where we got random names, greetings, phone numbers as a topic. So this wasn't really great for our use case. So then you might be thinking I'm alluding to a classification problem. So you're right, but there's an issue. So the issues with existing data is that I mentioned briefly about the shallow taxonomy, where the current taxonomy is purely based on heuristics. We have some SMEs go into the problem and say, you know what, that sounds like some problems that we're having, so we're going to make opening account as one of the topic. Now, a lot of them obviously is great, but it's not representative, and we have no guarantees of that. And also it's very limited to high-level grade because it's something that we just heuristically find out. And also another issue is that because this is not representative, some issues are just not applicable based on the answers in the category, and they're not always categorizable accurately, even by SMEs. And it's also not flexible to account for new issues. So for example, we had an issue where Luna coin went down and got delisted, and it started popping up. We weren't able to catch that within our taxonomy, so that was one of the issue. Other thing is the noisy data. I told you that SMEs only are accurate. They're only accurate 65% of the time. Now, either this is because even having SMEs doing the manual labor is very tedious and it's prone to fatigue, but also it's not as obvious, which I'll show you in the example later. Again, even if the SMEs are not able to do it accurately, clients are not likely to do it accurately either. So they are around 60% accuracy for the clients. And doing this incorrectly means that you're routing to incorrect teams, which they can't help you with. So then they need to be retried to another team, which is even hurting the SLAs even more. And I just want to mention that model built with suboptimal process, which means that suboptimal taxonomy, for example, only results in copying the suboptimality at best. So this is not something we wanted to do. So while they're exploring this, very fresh, ChatGPT came out, and then a little bit later, the API for the ChatGPT. Before the API came out, we actually were looking into, doing some hacky things to go from text interface to the web through some hacky terminal script code. So initially, we wanted to try out GPT models for direct classification, hoping that the underlying knowledge base that it was trained on is enough for us to use it directly. So first thing we tried is fine-tuning some of the GPT-3 models like DaVinci, Curie, and whatnot. An interesting thing is that if you're interested in doing this, I highly recommend converting the labels into numeric value rather than text value, because it tends to hallucinate a lot based on the labels, especially if they're longer than a few characters. And the other thing is that using prompt engineering on ChatGPT API. Now, the results were pretty good. It was promising, but it wasn't sufficient. And one of the primary reasons is that there's too much domain knowledge for zero-shot/few-shot learning. So you can imagine our product is called Wealthsimple Trade, and then Wealthsimple Invest. To an average consumer or average user, invest in trading means pretty much the same thing. Whereas a Wealthsimple is two different things. And Wealthsimple cash is just, fiat money or something. But for us, it's a product, right? So there's a lot of domain knowledge that is very hard to be represented as a just a simple prompt. Even if you chain them, you just risk, there's no guarantee that it's going to work correctly. So I see a question from Zara, which
Richie, I will ask the questions at the end. Let's
okay.
let's go through the presentation first.
Gotcha. Okay, awesome. So I'll continue. The outcome, yeah, again, there's a clear limitation in the current taxonomy that we found, and there's just no getting around to it. And we ran into like LLM specific issues. Mind you, this is like very fresh when ChatGPT came out. No one really had extensive study about hallucination, data omittance, small context window, and whatnot. So that was pretty interesting. So we realized that we can't just make this a silver bullet solution. So now we need to rebuild a taxonomy, but we don't have months to commit on it. Just for context, I'm the only dev/data scientist working on this problem. And I have 3-4 other projects that I need to balance with. So I can only provide some commitment on top of this. So now our solution was to leverage ChatGPT rather than a silver bullet solution, but as a part of model development. And I'll show you how. Before we get to that step, I want to talk about PII issue. We're using OpenAI, and especially in the beginning, it wasn't clear how the data was being used on the OpenAI side. I know they later mentioned about APIs not being used to train their own model, but either way, it's just a security concern for us to just simply pass in the data and simply trust OpenAI to do the right thing and not have a data breach. And we have a lot of sensitive data in the ticket. So you might imagine like SIN numbers, account numbers, address, personal names. So we want to make sure that we're doing a good job. So we partner with our legal team to build a state-of-the-art PI remover with Presidio and transformers. If you're not familiar with Presidio, it basically combines some of the features like regex, NER, checksum, context word anonymization components together so that you can anonymize SIN number as whatever you want it to be. And we compare this with the Satori, which is an application that we have for data masking internally for the Redshift tables and whatnot. We realized that it actually outperforms Satori by a significant margin. And we can add several layers of PI removals. So for example, depending on the application, you might be only interested in just removing the critical ones like crypto address or your SIN numbers. That might not be necessary. And then you might add, for example, names, addresses, which might be not necessary for some application, which might be for some other applications. And we do have plans to open source this, so stay tuned. So using LLM for topic and subtopic taxonomy. So we want to get a representative idea of what kind of topic and subtopics exist. So then we leverage ChatGPT to access the context of each inquiry and extract the topics. So then this goes in 3 steps. So get all the web tickets we're interested in. And for each of the tickets, we want to summarize or use the first X tokens. So a little bit more about the bias that we're introducing here is that a lot of the contexts are within the first few sentences that clients ask, because that's generally what we're interested in. So for example, I wanted to open a TFSA account, but it's not letting me to do that, right? So a lot of the contexts are in the beginning of the sentence, but also work equally well to use the summarization methods, ensuring that we have all the important context. So there's a little bit of prompt engineering there as well. In random samples around 50. So then we mix it around in case there's some sort of a pattern for seasonality or time of thing. We don't want to risk in a batch where all the examples only reside in one batch and the LLM just decide to hallucinate or omit that specific instance. Whereas if you mix it randomly, you are able to ensure that it's very unlikely that it's going to be omitted in every single batches. So we're just like playing the games of probability here. And we extract the common topics for each of the sentences. And assuming that we have large enough data, which we do, we get a representative set of all the summaries for each of the sentences. From here, you might the end state from at stage 1 of extraction might look like account opening an account, opening my account, right? Which are all the semantically same things, but they're just listed differently. So that at stage 2, we do the aggregation step, where for each of the generated topics, we ask ChatGPT to aggregate semantically similar topics together. And this actually works really great for getting all the level, whether you want it in the topic level, which is like some of the higher level, the subtopic level, which is in the lower and more detailed level. So we're able to generate a pretty representative topic and subtopic taxonomy just based on the steps alone. And just for context, if you were to do this step manually, it would have taken a month to get all this, and even that's not a guarantee that we're going to have a representative topics. And the nice thing about this is that if we just perform this exercise a couple times, for example, we just get rid of all the known topics, and then we want to run this exercise again through ChatGPT, then what we can do is that we are able to flexibly add in new topics should they come out. So for example, today we have this set of topics. Tomorrow, we talk about a new product. For example, Wealthsimple, I don't know, advanced trading. We say that we make that another product. Now we are able to have that as a new topic. Should we run this again? And then enough people ask about the topic, and they show up as a taxonomy. So we repeated this for both topic and subtopic. And now that we have those, we want to filter data to get relevant training data for. So then we basically built the labels of the classification that we want to do. So we used LLM to generate soft labels for our ticket data. So we tried zero-shot models from transformers, which didn't work out too great because it didn't have a lot of understanding of the context. But when you're using this as a, when you provide the taxonomy in the prompt, it has a pretty good context of what this is representing. So then given this taxonomy, classify the following text into one of those categories. Now, you might have an issue where some of the instances are omitted, and that's because it doesn't memorize everything 100%. But that's fine because we only need approximate data, right? So as long as you know, as long as you can route it to the original ticket, which you can easily, you can get a filter of what examples were relevant, and then you can just use that. It doesn't matter if 1 or 2 examples are omitted. You get a pretty good size of training data that just needs to be validated by human agents. So then you could use something like Prodigy, which is like labeling software by Spacey. In our case, we want to be hackier just to see if things are working. So we kind of did had a bunch of SMEs gathered up and labeled them in Excel. But whatever works for you. And the result was that most of them were identified correctly. It's just that some of the use cases just need to be changed or just flagged. And then we just use something else for that, or we just modify the labeling data, which work great for most of the majority classes. And we actually, the prompt that's in the example is not the same prompt that we use for this exercise because it's too long, but we did that using a few shot examples for each of the categories. And if you're interested, you might be able to parallelize this step as well, because a lot of the examples might take a while to run. So using LLM for data augmentation is interesting. I think this is the step that we're employing or exploring more recently. So for example, you can go from original sentence like, I want to open an RESP account for my son, to a synthesized example like, let me set up RESP account for my daughter. And you can do this through prompt engineering by changing the tone or specifying the client segment. For example, I am a 52-year-old dad with 2 sons and who are like 7 and 5 and interested in opening an account, right? So if you know the topic and if you know the original sentence, you can synthesize using this different characters of the conversation to generate an example. Obviously, it might not be correct 100% of the time. So for example, if you want to separate this by the account type level, for example, instead of RESP, you want to separate this with TFSA and RSP. This augmentation might include all of them together. So then there is this still step of human validation, Or if you just want to be hacky, you can just add a flag for augmented data and then just try training and then see if that improves your results. So then we put this all together. So then we built Ernie, which stands for Efficient Routing for New and Improved Efficiency, which is just to say this is trained on distal BERT models, which is ensembled together for topic and subtopic predictions. The result is that we mentioned that only 60 to 70% SME accuracy. This model results in 85 to 90% Ernie accuracy, and we're only working on to improve it even more. This has a 620 days worth of work per year from manual labor side, saved per, and this is by conservative measure. Soon, we're no longer going to require clients to identify their inquiry altogether once we put this model in full throttle. Right now, we're doing like a shadow of like 20% or some of the volumes or specific categories, actually. And this is going to result in better SLA and smoother experience for the clients. This model specifically is not the main focus topic, so we'll keep it light, but it was still pretty cool. So you can see it as a glance. So chat web tickets comes in, and we're also doing phone transcription soon. I don't know if you're going to be using a vendor or something like Whisper, but phone transcriptions to be added as well. So then those texts goes into the topic classification model, which, for example, like account maintenance. And then each of the topics have a subtopic classification model. So then the final prediction gets stored in our Redshift table. And this also gets updated to the Zendesk for routing. This is more in detail of the stuff that I talked about, like generating new taxonomy and data masking, training BERT models, and then doing level 1, level 2 predictions and getting final output. But yeah. So I just want to mention something cool. It's that now stakeholders can monitor model performance and label the data accordingly. I mentioned that a lot simple we're people bound, we're resource bound by people. Time is what's stopping us to work on some projects. So we need to be really smart on how to manage some of the projects. And I want to give the power to the SMEs who are in a better position to do the labeling and improving performance. I provided them scripts or endpoints to schedule the training and deployment themselves. And it's sort of a check-in process to see if we need to any help with the augmentation process or data cleaning up some of the training data. So yeah. So before we wrap up, I just want to show some examples on the output. So for the text, I want to open TFSA trade account. You can see the labels probability prediction model version. So the final prediction was account maintenance, management, and troubleshooting, which is right. But I just want to point out something that it's not always the model's fault. For example, I want to open TFSA trade account can be relevant for both account maintenance, management, troubleshooting, as well as money movement. And you can see that the probability is high for, it's not that different from 3.8, 0.38, and then 0.36. And that's because these types of contexts happen in both categories. So that's the domain knowledge that struggle with just using general ChatGPT. Because clients can transfer from another institutions and open TFSA in our account. So now, obviously, the more context the user adds, the better this prediction or the more distinct probabilities that you're going to be experiencing. And this is the subtopic where it was able to highly predict 84% for opening an account, which is right. And I still haven't received my cash card. Can you send it to my house again? So then this is more obvious. So it predicted to a cash card and account. And I still haven't received my cash card. And that was the prediction for subtopic of card delivery delay and replacement, which is also correct.